Jai Hind to all. I am Dr. Saroj Kushwah, Assistant Professor in CSE Department of Akgec Engineering College, Ghaziabad. Today I will discuss about the remaining part of graph, whatever I have discussed in the previous video. First, the connected graph. This is the figure of the connected graph. Connected graph means a graph J is said to be connected graph if there is at least one path between every pair of vertex in G. Otherwise, G is called disconnected graph. This is a graph. If the every pair of vertex connected with the edge, then it is called the connected graph. If there is no edge between the suppose this is a vertex and this is B vertex, if there is no edge between the A and B, then it is called as a disconnected graph. Key feature of connected graph. Here we explain about the key feature of the connected graph. First one is a path between every pair of vertex. Then it is compulsory in a connected graph there is having a path between the two vertex. You can travel from any vertex to any other vertex through the series of edges. Series of edges means if you want to connect with A, B, C, D, E, G, then if you want to move or travel from A to F, then you can connect it A, B, D, E, and C, a series, in a series. This is the defining characteristics. No isolated vertex. No isolated vertex means every vertex has at least one edge connecting it to the rest of the graph. Means here at least one edge between the two vertex. Single component. A connected graph has only one connected component. Second, if a graph has multiple disconnected components, it is called the disconnected graph. Means there is no edge between the vertex. Fourth one is the useful in network model. In a communication transportation network, being connected means the message or resources can travel between the two nodes given in any graph. Fifth one is the traversal covers all vertices. Using algorithm like DFS and BFS, depth first search and breadth first search algorithm. Starting from any vertex, then you will be able to visit all other vertex if a graph that is connected. Traversal covers all vertices. Using algorithm like means DFS and BFS, all vertex are connected to each other. Then next one is the can be directed or undirected. This graph can be directed or undirected. The undirected connected graph means simple symmetric connections, and directed connected graph there is two types: strongly connected and a weakly connected graph. The strongly connected, here the every node is reachable from every other node following the directions. Strongly connected means here it is compulsory to follow the directions. And a weakly connected graph, connectivity hold if the directions are ignored. If there is no directions, then it can be ignored, and connectivity hold of the weakly connected graph. The example of connected graph is imagine a transport network where nodes representation in cities and edges representation of roads. A connected graph ensure that there is route between any two cities, facilitating seamless travel. means there are the between the it is the node you can imagine the cities, and the vertex between the two edges we call the road map. Two facilities, two it is provide two facility between the two cities. Advantages of connected graph. There are 5 advantages of connected graph which I have mentioned in this slide. Guaranteed to first one is the guaranteed to reachability. Here you can always reach any node from any another node, which is crucial for things like communication network, roadmap, and file sharing system. These are the applications of the connected graph. Then second one is the efficient travel and searching. Using the algorithm like VFS and DFS can travel the entire graph from any starting point to the restart to similar nodes. Fourth one is a stronger network reliability. In a real world models like internet or power grid, a connected graph ensure uninterrupted flow and access. Fourth one is a simpler algorithm design. Many graph algorithms such as Dijkstra, Prim's, and Klusker algorithms. The example of simple algorithms design whichever used in a graph assume or work based on the connected graph. Next, single component. Here, single component means easier to manage and understand structurally since there is no isolated. There are different advantages of the connected graph. Number one, higher edge count, more memory usage. Because there is a number of count is high, so more memory you can used by the system. To manipulate connectivity, here the more memory uses for the maintenance, the connectivity, and you need the more edges which increase the memory usage, especially in a dense graph. Second one is the vulnerable to bottleneck or overhead. Since everything is reachable, certain hub nodes may become overloaded or crucial point of failure. Next is the not real ideal. In case access control or privacy, example social network, full connectivity may not be desirable. And following it more complex update. If the graph needs to remain connected after addition, removal, extra logic is required to maintain the property of a connected graph. Next one is the may increase cost in a weighted graph. May increase means because there you need to more edges, which increase the memory size. So keeping all the nodes connected can lead to higher load edge weight. So especially in minimum spanning tree and network layout. Another example is the directed graph. It is the directed graph. Example of directed graph. First we discuss about what do you mean by directed graph. Another name for the directed graph is a digraph. If all the vertex or node of a graph has directed or have a definite directions, then by the directed edges we mean the edge of the graph that have a directions to determine from which node is starting at which node is ending. Here in a directed graph there is compulsory to give the direction. Here the direction from A to B and C to D and A to D, also D to C, and you can give the direction from C to A. So here in a directed graph we provide the directions in this graph. all the direction. As we seen in our previous graph, all the edges for the graph need to be directed to call it a directed graph or a digraph. All the edge of a directed graph or digraph have a directions that will start from one vertex and end at another. The graph that is displayed above is an example of an connected graph. This graph also called as a connected graph because there are 4 vertex A, B, C, D, and there are also 4 edges between these all vertices of a graph, and all vertex present between the different node of a graph are directed or pointing to some other vertex of the given graph, which means the edge have a specific direction assigning to them. For example, consider the edge that is present between vertex D and vertex A. This edge shows that an arrowhead is pointing towards vertex A, which means this edge start from D and end at vertex A. Means in a previous graph started from A and end at D. Key feature of the directed graph. Key feature of directed graph, edge have directions. All the edge given in any graph, if there is directions, is compulsory for the connected graph or a directed graph. Then each edge, first edge have direction. Each in a directed graph, each edge goes from source vertex to the destination vertex. Second is the asymmetric relationship. Means A tends to B does not mean B tends to A exists. If a direction given to A tends to B, then it is not compulsory to direction from B to A. There is relationship between B to A. The relationship is a one way unless explicitly defined both way. Can have self loop. A node can have self loop means the A is pointed to itself, means the A tends to A. The edge pointing to itself means A point to itself. It calls the self loop. Support complex structure means used in modeling hierarchical or sequential relationship like task modeling, page linking, and a state transition. Last one is the can be strongly or weakly connected. Like a connected graph, the directed graph can be strongly connected or a weakly connected. Every vertex is reachable from every other following directions. Weakly connected means the connectivity exists if you ignore the directions. If you ignore the directions, then connectivity exists. Advantages of directed graph. Models real world scenario accurately. Next, perfect for representing one-way relationship like pre-request means course A must be done before the course B. Wavelinks, data flow diagrams. Next, more control and flexibility. Directions allow for more specific relationship and analytics like dependency tracking. Useful in a algorithm design. Crucial in algorithm like topological sorting, PageRank, and flow network. Last advantages of the directed graph is efficient for tree-like structure, ideal for representing parent-child or cause-effect relationship. There are 4 disadvantages of directed graph. It is a more complex to implement and traversal. One-way connection may limit reachability, harder to analyze connectivity, and increase algorithm complexity. First, The first one is it is need to consider age direction during the travel. Example, DFS or BFS. Second, one-way connectivity may limit reachability. Means not all node may be reachable from the given node, unlike the undirected graph. Harder to analyze connectivity. In a harder to analyze connectivity require more checks for strong or weak connectivity. Next one is the increase algorithm in a complexity. Then algorithm like cycle detection, shortest path or traversal require careful design to respect direction. Directed cyclic graph. It is also known as a DCG. Directed cyclic graph is a directed graph that contain at least one cycle. If it contain at least one cycle, then it is called as a directed graph. In a directed graph, there is cycle from A to B, B to C, C to D, and D to A. Means if some another, this is another graph. If there is cycle between A to B, B to C, C to D, and D to E, then at least one make one cycle, then it is called the with the direction, then it is called as a directed cyclic graph. A cycle being path that start and end at the same vertex. Then in this graph, start and end at the same vertex. Means here the start and end at the same vertex. A cycle means you can follow a set of directed edge from a node and return to the same node without retracing any edge. Key feature of directed cyclic graph. Directed edge, all edge have a specific direction. Presence of cycle, at least one path from a loop cycle from the edge directions, not suitable for some algorithms. And the directed cyclic graph is not suitable for topological sort because of the cycle. Can represent repeating process, often used to model system where thing can loop or repeat. Advantages of directed cyclic graph. The first advantage is useful in modeling real-world loop. It is used to final state machines, network routing loop, and feedback systems. Next is the flexible structure. The flexible structure means the graph can represent both linear and cyclic behavior of the one model. After that, dynamic relationship. The suitable band relationship between entities and change over time or a circle back. Last is the compact representation. In a compact representation, cycle allow reuse of nodes path, making the graph more compact for the loop-like system. Disadvantages of directed cyclic graph. Cycle detection, numeric cycle detection complexity. Extra logic is required to detect the handle cycle, and some algorithm like topological sort, which I have told about in previous slide, cannot run if cycle are present. Can lead to infinite loop. In traversal or computation, cycle may cause infinite loop if not handled carefully. Harder to analyze, more complex to analyze for reachability, dependency, and termination. Fourth one is not always predictable. Cycle behavior can have system unpredictable or unstable in some models like logic, circuit, or scheduler. Undirected, next one is undirected cyclic graph. In an undirected cyclic graph is a graph without direction to its edge. In this graph there is no direction. Notice, since it is undirected, you can travel in either direction along the side. You can travel A to B or B to A. You can travel B to A, means you can travel in a both direction. You can travel in both edge have no directions. You can travel edge in a both direction freely. Move from A to B or B to C. Second, contain at least one cycle. In a directed cyclic graph, also contain a one cycle as a directed cyclic graph. Not a tree. A tree in a cycle connected graph. A tree is an acyclic because in a tree there is no cycle. That's why the undirected cyclic graph is not a tree. May have multiple cycles. In undirected graph can have many overlapping and separate classes. Advantages of undirected cyclic graph. Number first, more redundant path. Means cycle provide alternate route between the nodes, useful for fault tolerant system like network routing and transporting system. Second one, better connectivity, higher likelihood of staying connected even if one path is fails. Next is the useful in real world models. Common in city real world model में it is used in common city map, social network and mass network, etc. Fourth one is a simpler travel logic. Simpler travel logic means there is no direction to follow to travel. Algorithm like VFS and DFS are straightforward. Disadvantages of undirected cyclic graph. Cycle detection needed. Algorithm must handle cycle carefully to avoid infinite loop during traversal. Not suitable. Second one is the not suitable for hierarchical model. It means you cannot represent parent-child or pre-request relationship cleanly. After that, we explain the can be computationally expensive. The extra logic is needed to detect or eliminate the cycle for the certain applications such as spanning tree constructions. Harder to simplify. Cycle can make the cycle dense and harder to analyze or visualize. Next one, loop graph. What do you mean by loop graph? A loop graph is a graph in which one or more vertex have edges that connect back to themselves. These self-connected edges are called the loop graph. Means there is the edge A. If edge is connected to the again A, then it is called the self loop. It is similar term as a loop in an edge where the start and end vertex is the same. The start vertex is A in this loop and the end vertex also the same. Key feature of loop graph. Key feature of loop graph means first contain one or more loop. At least one vertex have an edge pointing back to the itself. Second one is can be directed or undirected. Directed or undirected means loop can exist in both type of the graph. Third, effect degree of a node. First, a loop add 2 to degree of the node in undirected graph and 1 to in degree and 1 to out degree in a directed graph. Next one is a may or may not contain cycle. A loop is a cycle of length 1. The length of the loop is the 1. Advantages of loop graph. Model self-referential relationship. First, useful in system where something refers to itself. It is used in recursive function, self-dependency and feedback system. Next one is the increased flexibility in modeling. Allow more accurate representation of real-world system with self-interactions. Next one is important in state machines. Loop represent situations where a state can transition back to the itself. The self loop is used used in the applications where the application is repeatable or the iterations. Disadvantages of loop graph. First one is a complicate some algorithms. Algorithm like cycle detections and sorted paths may need extra logic to handle self loop. In this path means shortest path or the cycle detection, the self loop may be very complex to recognize, may not be meaningful in some context. In some context, like a tree structure or a certain type of network, self loop have no useful interpretations. Third, can mislead structure analysis. Loop can distort calculations like node degree connectivity and clustering.